Welcome back to another episode of Everyday Nuggets. Have you ever worn shoes with Velcro straps? Or used a Velcro wallet? This remarkable fastening system has revolutionized how we secure things in our daily lives. Yet most people have no idea how it's actually made. Today, we're going to pull back the curtain on one of the most ingenious inventions of the 20th century. The story of Velcro begins not in a laboratory, but in the Swiss Alps. In 1941, an electrical engineer named Georges de Mestral went for a hunting trip with his dog. Upon returning home, he noticed that his pants and his dog's fur were covered in burdock burrs, those annoying seed pods that stick to anything they touch. Instead of simply brushing them off in frustration, de Mestral was curious. He examined one of the burrs under a microscope. He discovered something fascinating. Each burr was covered in hundreds of tiny hooks that could catch on anything with a loop, like clothing or animal fur. This observation sparked an idea. What if he could replicate this natural mechanism to create a new type of fastener? This moment of inspiration demonstrates how some of our most useful inventions come from biomimicry, the practice of imitating nature's designs and processes to solve human problems. De Mestral's journey from inspiration to actual product took nearly a decade of persistence. He experimented with various materials, trying to create both the hook and loop elements that would replicate the burr's natural fastening ability. After much trial and error, he settled on nylon as the ideal material. Nylon had only been invented a few years earlier. Still, it possessed the perfect combination of durability and flexibility needed for his fastener. But having the right material was just the beginning. De Mestral faced a significant challenge. How could he manufacture the tiny hooks needed for his fastener? The solution came through collaboration with a weaver from a textile plant in France, who helped him create a process to weave the nylon and then precisely cut the loops to form hooks. By 1954, de Mestral had perfected his manufacturing process and received his Swiss patent, with the US patent following in 1955. He had already established Velcro SA in 1952 to commercialize his invention. He named it Velcro, a combination of the French words velours, velvet, and crochet, hook. The production of Velcro involves several precise steps, each critical to creating a practical fastener. Let's break down the fundamental process. First, manufacturers create two separate strips of nylon fabric. One will become the hook side, and one will become the loop side. For the hook side, the nylon is woven into tiny loops covering the entire surface. These loops are then precisely cut on one side, creating thousands of small hooks. For the loop side, the nylon is woven into longer, thicker loops that remain uncut. The process requires specialized machinery that can weave these intricate patterns, and for the hook side, cut the loops with perfect precision. Too much cutting would create weak hooks that break easily. Too little would result in ineffective fastening. After weaving and cutting, both sides are heat-treated to set the hooks and loops in place, ensuring they maintain their shape through repeated use. Finally, the backs of both strips are coated with a resin that adds strength and allows them to be attached to other materials. The result is two strips that, when pressed together, form a surprisingly strong bond. Yet they can be easily separated with a simple pulling motion, a perfect balance of security and convenience. Once the Velcro components have been manufactured, rigorous testing begins to ensure the product meets strict quality standards. Each batch undergoes a series of tests to evaluate its strength, durability, and functionality. Testing machines apply pressure to fastened strips, pulling them apart repeatedly to measure their cycle life. Premium-grade Velcro can withstand thousands of openings and closings. At the same time, industrial-strength variants are tested for their ability to support significant weight under various environmental conditions. Quality control inspectors examine samples under microscopes, checking for uniformity in hook and loop formations. any manufacturing defects, such as misaligned hooks or insufficient loop density, are identified and corrected before the product reaches packaging. Did you know that aerospace-grade Velcro must pass additional tests for flame resistance and performance in extreme temperatures? These specialized variants ensure safety in critical applications where failure isn't an option. After passing quality tests, Velcro strips move to the packaging department. Here, the continuous rolls are cut to precise lengths according to customer specifications. Some are packaged as long rolls for industrial use, while others are cut into more petite consumer-friendly strips. For retail products, Velcro is often mounted on cardboard backings with usage instructions and branding. Industrial quantities are typically wound onto large spools for efficient distribution to manufacturers who incorporate Velcro into their products. The packaging process itself is largely automated, with machines cutting, folding, and sealing packages at high speed. This automation ensures consistency in packaging while keeping production costs competitive in the global market. Distribution networks then carry Velcro products to destinations worldwide, from local craft stores to major manufacturing facilities that use Velcro in everything from shoes to spacecraft components. As with many synthetic materials, traditional Velcro production raises environmental concerns. The nylon used in conventional Velcro is petroleum-based and non-biodegradable, potentially contributing to plastic pollution when discarded. In response to these concerns, manufacturers have begun developing eco-friendly alternatives. Bio-based Velcro substitutes plant-derived polymers for some petroleum ingredients, reducing the carbon footprint of production. Other innovations include biodegradable Velcro, made with modified natural fibers that break down more readily in landfills. Some companies have implemented closed-loop manufacturing systems that recycle production waste, minimizing the environmental impact of Velcro manufacturing. Additionally, water conservation efforts and energy-efficient machinery have become standard in modern Velcro factories. How significant are these eco-friendly innovations? While they represent essential progress, completely sustainable Velcro remains a challenge that continues to drive research and development in the industry. The future of Velcro extends far beyond its familiar form. Engineers are developing smart Velcro with embedded sensors that can monitor tension, pressure, and environmental conditions, ideal for medical devices and structural monitoring applications. Micro-scale Velcro, while distinct from de Mestral's original burdock burrs-inspired invention, uses microscopic hooks that mimic gecko feet's adhesive properties. Unlike traditional Velcro, these tiny structures can adhere to almost any surface without matching loop material. This technology could revolutionize industries from robotics to temporary building construction, creating entirely new applications beyond what de Mestral initially envisioned. Researchers are also exploring biomimetic fasteners that combine the principles of Velcro with other natural adhesion mechanisms. These hybrids might one day create reversible adhesives with the strength of permanent glues, but the reusability of Velcro. From Georges de Mestral's inspiration on a hunting trip to today's high-tech manufacturing processes, Velcro represents one of the most successful examples of biomimicry in human invention. The seemingly simple hook and loop system has evolved into a diverse family of products, serving countless applications across virtually every industry. Next time you hear that distinctive ripping sound as you open your shoes or jacket, you'll appreciate the complex journey from raw polymers to the finished product that helps hold our world together, one tiny hook at a time. Thank you for watching another episode of Everyday Nuggets. If you enjoyed this episode, please like and subscribe for more videos. If you have suggestions for other everyday objects you'd like to learn about, please leave them in the comments below. Stay curious.